Hello everyone. In this video of attributes of polynomials, we're going to be discussing maximums and minimums, also known as max and mins. How to identify them, what do they look like, and how to categorize them. So let's get started. The first thing you want to be able to do is identify the difference between a maximum and a minimum. The easiest way I can put this is a maximum is a high point on the graph and a minimum is a low point on the graph. So regardless of what the graph looks like, let's just say we have something like this. Okay, just to clearly or just labeling them, these points are going to be the ones that I'm going to be interested in, right? Notice how here I have a general high point on the graph, right? A bit of a hill. And down here I have a bit of a valley. Down at the bottom, I have a low point on the graph. So I'm going to just label these as max and mins. This is my maximum, and this is my minimum. Now, a polynomial can have more than one maximum or minimums. Maybe it just has minimum and no maximums, right? Things like that. So we're going to get into several examples to identify maximums and minimums. And more importantly, there's a difference between local and global, and that's what we're going to get into here next. But maximum is a high point on the graph, and a minimum is a low point on the graph. So let's dig deeper. Local versus global. To show this example, I'm going to first do a graph to better show you what things look like. So let's sketch something real quick. Okay, now the first thing that I like to do is I like to label my critical points, or my points of interest. I have one here, and one here. Once I label them as minimums and maximums, as I will do here in a minute, here I have a high point, so I'm going to call this a maximum. Here I have a low point, I'm going to label it a minimum. And here I have a high point, so I'm going to label it a maximum. Once you label them, the difference between local and global is really just local is a relative maximum, and global is the maximum of the entire graph. So think of local as something that is regional, something that is in the area, and global is the big picture. So if I focus specifically on this first maximum right here, right? If I look at this picture right here, or this one for example, I look at my point and I look at it, okay, this is, in this region, it is a maximum point. But in this region, is it a maximum, or out of the entire picture, is it also a maximum? What can I tell? Well, out of the entire picture, this isn't just a maximum, it is the highest point in the graph. Because it is the highest point of the entire graph, I automatically label this as a global maximum. Let's go to the other maximum as an example. Here, I also have a maximum point. It's a high point on the graph. But is this the highest point of the entire graph? Notice how it isn't, because I have point higher over here on the graph. So because this is a maximum, but it's not the highest point, I call it a local maximum. Because relative to this area in this region, it is a high point. It is the highest point of all of the points around it, but not of the entire graph. And down here I have a minimum. So then my question is this point a low point on the graph or the lowest point on the graph? Because these arrows continue going lower and lower to negative infinity, this cannot be the lowest point on the graph. Therefore, we label this as a local minimum. So, a polynomial can have global maximums and minimums or local maximums and minimums. Maybe it's just full of locals and no globals. Or maybe there is a global maximum and a global minimum in the picture. It really depends on the picture. So to better explain this, or to get a better picture of this, let's do some examples. The biggest thing you want to take from here is that local is in a region and global is out of the entire picture. So you want to zoom out and look at the big picture, look at the arrows, where are they pointing? Is this the highest maximum or is this the lowest minimum in order for us to label it a global? So let's try an example out. See what it looks like. Feel free to draw these sketches with me, right? Pause the video and draw the pictures with me as well so you can get an idea of what we're doing. So here I'm going to label my points of interest. I have one here, I have one here, I have one here. I have 3 points of interest, right? Out of these 3 points of interest, I'm going to label my maximums and minimums. Here I have a minimum because it's a low value. Let's draw this sketch a little bit better so that we can have a clear view of what we're talking about. Sorry about that. So let's say we have something like this. I want to make things a little bit more obvious for you so that there's no question about what things look like. So I have a point here. Let's label this a minimum because it's a low point on the graph. Let's label this one a maximum because it's a high point on the graph. And let's label this a minimum because it's also a low point on the graph. Okay? Now, when I'm looking at this first minimum, I think, is this minimum the smallest minimum of the entire graph? Is it the lowest of all of the graph? And as you can see, it is not the lowest point on the graph. So I simply label it as a local minimum. Then I go to my maximum. Is this maximum the highest point of the entire graph? Notice how the arrows continue to go up, which means there's more points up here that are going to be higher than this maximum. So because it is a maximum, we call it a maximum, but it's not the highest maximum. So we just label it a local maximum. And finally, down here we have a minimum. My question again is this the lowest minimum of the entire graph? And notice how there's nothing below this point. So that point becomes the global minimum. Let's try another one out. So let's say we have, let's try an odd function. Okay, it's an odd function because the arrows are pointing in the opposite direction. Let's label some stuff here. So I have a maximum here because it's a high point on the graph. I have a minimum. I have another maximum. And I have a minimum. Now, as I'm identifying these, I want to ask myself, is this the highest maximum of the entire graph? No. Therefore, it is a local maximum. What about this minimum? Is it the lowest point in the graph? No, because there's lower points on here, right? Therefore, local minimum. Up here we have a maximum. Is this the highest maximum in the graph? Now, it looks like it's higher than this one, but is that the highest point the entire graph will reach? No, because the arrow continues to positive infinity, which means there are numbers up here in the graph that are existing higher than this maximum. So we label this one also a local maximum. Finally, we have a point down here, the minimum. It looks like the lowest minimum, but notice how this arrow continues to go further below that point to negative infinity. So this cannot be the lowest minimum, so we just call it a local. Notice how in this graph, we have no global maximums or minimums. That is also a possibility. This is also an odd function. Because it's an odd function, the arrows are always going to go point in the opposite direction, one going to negative infinity and one going towards positive infinity, which means odd exponent or odd degree functions will never have a global maximum or a minimum, just locals. Let's try one last one. Again, I encourage you to draw these and try them yourself. You can pause the video, you can give this a try, and then answer the question with me. All right, so I have several maximums and minimums. Here I have a maximum point. high point on the graph, I have a minimum, a maximum, minimum, and another maximum. I know I got carried away there. So I have 3 maximums. Out of all of the maximums, is there a point that is the highest maximum of all of them? That one in the middle. There's no point higher than this one. So I'm going to label this one global. And the rest, local. There can only be one global unless there are 2 globals that are at the exact same height and they're both at the same level at the very top of the peak. But usually you only have one global. Let's look at the minimums. Are any of these 2 minimums the lowest of them all? The answer is no. Because these arrows go down to negative infinity, these 2 will never be the lowest of all the lowest points. So we call them both local minimums. So, biggest difference here is that global has to be dealing with the entire picture. Out of the entire picture, is this the highest point or the lowest point? That's how we can categorize it a global. If it is not, then it's just considered a local. Because relative to this region or this local area, it is a maximum, but it's not the maximum point. Same thing with these. Out of these points around it, it is a low point, but it's not the lowest, so we label it a local. I hope this is clear. Please let me know if you have any questions. Comment below and I can answer them for you. You guys have a great day, and as always, we'll calculate later.